Hello, I'm Miss Igo. Welcome to my classroom. In this video, we're going to be talking about factoring by GCF. GCF stands for Greatest Common Factor. This is the largest divisor or factor that both numbers have in common. Let's factor this binomial by finding the GCF. In this binomial, we have 6x minus 6y. Whenever we have more than just a number or a variable, let's look at each part separately. So if I look at the numbers, I have a 6 in the first term and a 6 in the second term. So they both have a 6 in common. That is the greatest factor, the greatest common factor that these two numbers have. They have other factors. 2 is a factor of 6. But 2 is not the greatest factor that they have in common. So our greatest number that these two terms have in common is a 6. Now let's look at the variables. If I look at the variables, I have an x and a y. Well, those are not common. They're not the same. So that will not be included in my greatest common factor. Once I determine what my greatest common factor is, I write it down, which I've already done, and then in parentheses after the greatest common factor, we're going to write what we would have left if we were to divide our polynomial by that number or that term. So if I were to divide each part of this binomial by 6, let's see what we would have left. The first term, if I divide by 6, the only thing that's left is an x. In the second term, if I divide by 6, I have the minus y left. So this would be my result once I factored by finding the greatest common factor. To make sure that this is the solution, we can check our answer anytime we factor. We can check our answer by multiplying the result back together. If we multiply it back together, we should get what we started with. So let's try it. If I have 6x minus y, if I were to multiply these back together, I would distribute the 6 into the parentheses. 6 times x would be 6x. 6 times negative y would be a negative 6y. Now, let's look at what we started with. I started with 6x minus 6y. So, because when I multiplied it back together, I got what I started with, I know that this is the solution when I'm told to factor. Okay, here's another binomial. Y to the third minus 8y. So like I said, anytime we have a polynomial, let's take each term and look at each part of the term. So if I look at the number part of each term, my first term has just an understood 1. So really we don't have a number to compare with the other number. So the only common factor that 1 and 8 would have is 1. So that's really, we're trying to find any number other than 1 to factor out. Because if I factor out a 1, if I divide by 1, it doesn't change anything. So now if we look at the variables, this first term has a y and the last term has a y. So we want to take as many y's as we can. There's 3 y's in this term, but there's only 1 y in this term. So we can't take 3 y's out of the second term since there's only 1. So the most y's that we can factor out would be 1 y. All right, so then I'm going to see what I would have left if I were to divide each term by y. So if I have 3 y's and I take away one of the y's, I'm left with 2 y's. Here, I have 1y. If I divide by y, that makes the y's go away, so I'm left with minus 8. Now again, if we were to check our factored solution by multiplying them back together, y times y squared would give me y to the third. Y times negative 8 would give me a negative 8y. And that's what I started with, so I know that this is my solution. Let's factor this binomial. We have 7x to the fourth minus 21x squared. So if I look at the number part of my binomial, I have a 7 in the first term and a 21 in the second term. So the greatest divisor, the greatest common factor between 7 and 21 is 7. 7 is the biggest number that can divide into both of those numbers evenly. Then for our variables, we have an x to the fourth and an x squared. So they both have x's. We just need to see how many can we take. So it's always going to be whatever the smallest exponent is, because since I have a 4 here and a 2 here, like I said before, I can't take away 4 x's out of this second term because there's only 2. So it's going to be the smallest exponent whenever we're dealing with variables. When we're trying to find the greatest common factor. So x squared would be our greatest, 7x squared would be our greatest common factor. So if I were to divide this first term by 7x squared, the 7's would cancel, and then for my variables, whenever I am dividing variables, I subtract the exponent. So I'm taking away 2 x's from the x to the fourth, so that leaves me 2. 4 minus 2, there's 2 left. So there's an x squared left whenever I factor out a 7x. And then in the second term, if I divide by 7x squared, this is a negative 21x squared divided by 7x squared. Well, the x squareds, they're just the same, so they're going to cancel out. Negative 21 divided by 7 would give me a negative 3. So this would be my solution. In this example, we have 16x minus 4. If I look at the numbers, what is the biggest number that will divide into both 16 and 4? Again, we know that 2 will go into both numbers, but that's not the biggest number that can go into both numbers or that can divide into both numbers. 4 would be the biggest divisor. The first term has an x and the second term does not, so that is not something that they have in common. The only thing they have in common is the number 4. That's the only thing they can both be divided by. All right, again, we put in parentheses what's left once we divide by that greatest common factor. So if I divide each term by 4, 16 divided by 4 is 4. And there's also an x left. Now, what is 4 divided by 4? 4 divided by 4 is 1, not 0. A lot of times I'll see students take this, if they're factoring out a 4, and they'll just cancel it out and say, oh, there's nothing left. Well, if that were the case, if you did this, if you said 4, if you factored out a 4 and you said what's left is 4x, and then that canceled out, and so we don't put a minus anything. If I were to multiply this back together, 4 times 4x, that would give me 16x. Well, remember I said anytime we factor, we're always able to multiply our solution back together to get what we started with. Well, here I didn't get what I started with. But here in the first solution, if I were to multiply these back together, this would be distributed, and I would get 16x, and then that would be minus 4 times 1 is 4. So this would be the correct solution, not this. So be careful of that. Anytime you factor out the same number, like we were factoring out a 4, don't just cancel that out. That's 4 divided by 4, which is 1, or negative 4 divided by 4, which is negative 1. All right, this is our last example in factoring by GCF. When I look at this, it looks a little complicated. This is a trinomial because it has 3 terms instead of just 2. So anytime I have something that's a little complicated looking, just take it one step at a time. So we know that we have 3 terms that we're looking at. We're looking at this term, and this term. Let's take it one step at a time and look at the numbers first. So I have 2, 4, and 18. The biggest number that will divide into all 3 of those numbers is 2. I can't do a 4 because 4 can't divide into 2 evenly, but 2 can divide into 2, 2 can divide into 4, and 2 can divide into 18. The next part of my term is an x. So this first term has an x, the second term has an x, and the third term has an x. So we know that x is going to be something they all have in common. And like I said, we have to use whatever is the lowest exponent. This x has a 3, this one has a 2, this one has an understood 1. So the smallest variable on our exponents, that's what we're going to use. So we're just going to have an x with an understood 1. Now for the y's, we have a y in the first term, a y in the second term, and a y in the third term. So they all have a y. They have y in common. And all of them are just a y to the understood first power. So that's what we're going to write as our common factor. So our greatest common factor is 2xy. Just like before, we're going to write in parentheses what's left if we divide each term by 2xy. All right, so in the first term, the 2's would cancel. We have a y on top and a y on the bottom, so the y's would cancel. So all that's left is x to the third divided by x. So that means we're taking away one of the x's from the top, and that just leaves us with x squared. In the next term, so make sure that we bring this minus sign into our equation. So minus 4 divided by 2 would be 2. Again, the y's would cancel. And then x squared, if I take away one of the x's from the x squared, that just leaves me with an x. And then bring down the plus sign. The y's are going to cancel. The x's are going to cancel. 18 divided by 2 is 9. And this is my factored solution. Again, if you wanted to multiply them back together to check your solution, you can do that. And that's how we solve, or that's how we factor by using the greatest common factor.